So yesterday we started exploring with the graphs of logarithms, and we did it in a comparison with our exponential graph. Today we are going to focus in on just the logarithm graphs, identify some key features, practice graphing different bases, starting with our base 2. So if we look here, we have a table over here with the headers x and our y equation, which is log base 2 of x. We are going to fill out this table for all of these different values of x. Starting with this first one. So I'll do this first one in detail here. We'll do this in red. And I'll kind of do it on the right-hand side. You have a little bit of scratch room if you want to on your note sheet. So we replace our x with that number there. So we'll get log base 2 of 0.0625. And I'm actually running out of space, so let me rewrite that a little closer. Log base 2 of 0.0625. And we can use our change of base formula to calculate that. So we'll do a fraction of 2 logs. Log of 0.0625 up top, log of 2 on bottom. And if we go ahead and calculate that, we will get -4 if we punch that into our calculator. We can similarly do that for the remaining ones here. Let me do a different example. This one in blue. Let's do it with 8 right here. If I do log base 2 of 8, okay, that will be equal to the log of 8 divided by the log of 2, and that will give me 3. And so 3 can go into that spot in our table. So similarly, we can go through and calculate the rest of these values in this table and start plotting these. So use your calculator, pause the screen, make sure you can calculate all these and unpause it when you're ready. I will fill out the rest of this table here. -3 for 0.125, -2 0 for 0.25, -1 for 0.5, 0 for 1, 1 for 2, 2 for 4, 3, and 4 for 16. So we're going to now actually plot all these points on our graph to create a nice log curve. So all of our x values in our left column, all of our y values are in our right column, and I'll use black for all of this just so we can identify some key features later. We're going to go to -4, and -4 down is our y, and that has an x value of 0.0625. So we are barely off our y-axis here. Then we go to -3 down and 0.125, so maybe a little further off, but not much, still really hugging that line. -2 goes to 0.25, so moving a little further, but not much. And -1 goes to 0.5. And finally, we get some nice clean points we can do. Add an x equals 1, which is right here. We are crossing our x-axis. All right, so I'll make that a little cleaner and make sure it's on that point there. So far we get a graph that's hugging that y-axis, coming up, and we cross our x-axis at 1. Then we go over, we get 2, 1, so over 2, up 1. We get 4, 2, so over 4, up 2. We make a big jump over to 8, 3, so over 8, up 3. And 16, 4, so all the way to our edge of our graph and up to 4. So all we've done is plotted those points, and I'll try my best with my computer here. I'm going to make a nice smooth curve connecting these dots. See how well we do it. And that should give us the shape of our logarithm here. So you guys should have the log base 2 graphed on your sheet. You guys should have that table filled out. And if you flip to the back of your sheet, you'll see that we have a key features table that we're going to start filling out. And on this screen, I've just included this first column here for log base 2 of x. we're going to fill out all these key features from this graph that I've included here on the left, just so we can see it and talk about it. So first off, we're going to fill out the domain of this graph, and that's all the possible values of x. So if we look here, we see that, hey, we have a graph that it's on the left-hand side, it starts to hug this y-axis. And if we were to continue plotting values, we would keep going down, but we would never actually cross that 0 mark, okay? So our left bound here is 0. Our x is always going to be greater than 0. So let's write this as 0 is less than x. But if we look at the right side of our graph here, all right, this graph would continue moving to the right all the time, right? We could go to 16, we can go to 32, we can go to an x equals 50, we can go to x equals 100,000 if we wanted to. We'll continue going. And the way we say continues on forever in math is infinity. So we're going to throw a positive infinity there. Then if we look at our y values, so the range, the possible y values, we look at the left side of our graph, it keeps going down, like I said. It'll never cross 0, but the y will continue to go negative forever. So we'll be bounded by a negative infinity is less than y. And on the right side, same thing. The graph seems to level out a bit, but that y is always going to be increasing. It may take a while because it really gets flat, but our y is going to, we could theoretically get any value of y as we keep going. So positive infinity on the right there. Then if we look, we want to find our x-intercept. So that's where we're crossing our x-axis. We kind of talked about that as we were graphing. I'll circle it on our graph here. That happens at x equals 1. So our x-intercept is at x equals 1. Our y-intercept, let's do that one in green. It's where we cross the y-axis. And as we kind of talked about in our domain, since we're bounded by 0 here on the left, this does not exist. So our y-intercept does not exist. With this graph, we are never going to actually cross that y-axis. Our value is never going to get negative. We're always going to have positive values of x. Then we can look and see, and this is a key point just to kind of observe behavior on our graphs, the point where y equals 1. If we look here, we go find y equal to 1, kind of trace that over. That is going to be right here. And let's write this as an ordered pair, all right? So our x value is 2 here. So that means our ordered pair is going to be 2, 1. X equals 2, y equals 1 at that point. And finally, the last two things we kind of already talked about with our domain conversation, that first thing we filled out. Our behavior as x approaches 0. Again, that's as our graph is moving towards 0. Our graph is going down to negative infinity, right? It's going to keep going down forever. Similarly, as we approach infinity with our x, as we move to the right, our graph is going to continue to go up. It'll go up slowly, but it'll continue to go up. So we are going to approach positive infinity. So you should have enough knowledge here to add our base 5 and base 10 logarithms to our graph. After that, we should be able to label them so we know which one we're looking at and fill out the rest of that key features chart in order to complete our notes for today. We're basically repeating that process. Fill out those tables, graph the equations, and then fill out that key features chart.